Don't mind me. I'm just wiping down my sheet.
Okay, so
I almost said something.
okay, so we're gonna start with a little bit of math here. So let me go ahead and actually not initialize this stuff. I wanna actually show them how this stuff can mess up, because that's my favorite part.
Yeah.
So when you don't initialize your variables, what you're actually doing is you're just telling the computer that you want space to store a variable. But if you don't give it a value to put in that place for storage, then whatever was in there has the name of the variable, but it still contains what it previously had. So it can be a bunch of trash. So let's go ahead and let me fix this line just because it's ugly. Alright, so we're going to just add to this program. So as we can see, we got input.
Use the mouse. Don't point at the screen.
Oh, that's right. I really wish we had a camera. Okay. So right here we get the input from the user, right? And we're gonna show them the input right here. Now we're gonna play around with it with some math.
And math is as simple as you think it is. It's just like writing math on a piece of paper.
We can just output it.
Yeah.
We can do something like I plus 10.
I plus 10. And that I plus 10 will get evaluated and then printed out. So.
We can't do math with a character. Delete one.
Yeah. Oh, you can. This character just ASCII value.
Oh, that's right.
Bruh.
Why would you do that?
I don't know. Well, if you wanted to change something from lowercase to uppercase without using a crazy function, that's easy. But we'll just stick with the numbers this time. We should probably just stick to the numbers.
What you mean?
For the math.
Yeah, those are numbers.
Yeah, I know.
I'm gonna add a little decimal point for the float and the other one though. And there we go. So what we're doing right now is we're just adding it inside of the output statement. So it adds it before outputting. It's not actually changing the value of the variable. Well,
Yeah.
I'll show you how to change the value of the variable.
Well, you can
right
even do another.
this.
Yeah, show them afterwards that the variables don't change this way.
So let's go ahead and run it. And let's start. I'll put some different ints. I'll put 9. I'll put like 5.5 and like 3.4. Oh, character. E. Okay. So, since we didn't clear the screen, it's still up here, so we can see it. 10 plus I, and I was 9 when I entered it. It's 19.
Yep.
Then we do 5.5 plus 10. 0.5. Oh, I put a decimal in there. I forgot. Wow, freaking lapsus over here. Okay. Yeah, it's working. But it chopped off. Yeah, we need to show them set precision next. Yeah. See, as you can see, when you just output just this way, and you don't specify how many decimal points you want,
those extra ones get chopped off.
Yeah,
after one.
it just does it on its own. It just rounds off at 1. I would think it would actually do for more for double, but it doesn't.
Yeah.
All right. Well, as you can see, it works. I really don't like math even addition. Can you believe that? All right. So let's actually change the values of our variables. Unlike in math, we can do some funky looking stuff over here. We can set the value of I equal to I plus 10.
Yes. Now remember that what's on gonna what happens on the right hand side of the equal sign, that gets evaluated first and then stored into the left hand side. If that made sense. I think it did. So when it gets down to these lines, it's going to do I plus 10 with that value stored into I. And you have to, there's a difference, we'll get into it a little bit more with assignment statements and, what's that word?
Hmm?
When it's equal to, yeah. Pretty much one equal sign versus two equal signs.
Oh.
Assignment versus equality.
Assignment versus equality, yeah, you got it.
That's the word.
I need this last one right here. Okay, so make sure that when you're trying to replace a variable, you only see one equal sign. When you do two equal signs, you're testing for equality. So one equal sign, you're assigning whatever's to the right into the what's up to the left. So the variable to the left gets put with this value.
Correct.
And then when you have two equal signs, you're testing for equality. So what you're actually checking is if the two variables are equal.
Yes. Which we'll show you in a later video.
Uh-huh. So as you can see, I did the math this time on the variables. In this output right here, the variables are actually not changed, and I can actually show you that too. Let me just go ahead and show you. Boop.
There we go.
So basically what's going to happen here is I am going to go ahead and output the variables right after showing you this math and show you that they didn't change. And then this is going to happen right here. What?
We don't need that.
Oh, the character one. Correct. Okay.
But yeah, we'll show you what the output is, and then when we don't assign it back into, and then what happens when we do reassign it.
By the way, the math happens incognito. You can't see it.
Yes, it won't be displayed. Only thing that gets displayed is anything that you put a C out to.
And just so we know where there's a separation from here, I'm just going to enter a character into C.
Okay.
Just put a little C out.
It just doesn't matter. Sounds good.
Alright, let's try it. Hopefully I didn't make any mistakes. Yay, I'm not losing my touch. Okay, give me some numbers.
3.
3.
3.14. 97.1. F.
Alright. So, it outputs them the first time. It does the addition. It outputs them a second time. As you can see, it's exactly the same.
Yeah.
We
didn't save over them.
Yep, we didn't change the values inside of the variables. And we just didn't output the character, so that's not there. But everything else is the same. And now I am going to go ahead and type in another character. This E, because this is our little separator I put. Otherwise, if you don't have an input statement or something like that, where you're actually getting something from the user, your program will just execute really, really fast, because computers are really, really fast. So, yeah, he'll just go.
I didn't know that.
He'll just go all the way down your code if you don't have an input statement. The input statement is basically the only thing that stops your program. And
yeah, and other things.
And a couple of other things that's a little bit more advanced. Alright, so I'm going to go ahead and press E. And there are my variables after I actually did the math.
The second set of math we didn't show on the screen because we didn't throw a C out on them. That's the I equals I plus 10, things like that.
Yep. All that is incognito, happens in the background. You actually don't see it. Once again, the only stuff that you see is stuff inside of the output statements, which is my eyes.
Epilepsy.
All right. Should we show multiplication, division, and all that other stuff?
You can. I mean, you can show them division and show them that
it
the
chops
decimal,
off. Yeah.
The integer division. Oh yeah, integer division and double division, stuff like that.
Okay, I'll just show them an integer division real quick.
So when it comes to our data types in math, it makes a huge deal. So especially with like division and multiplication. If you do division, multiplication, and even addition and stuff like that with two different types like integer and double, it's going to cut off some of the decimal points possibly. So if you do what Puga is probably going to show you is a mixture of the two data types, you'll see what happens.
So this time we're going to put in the same variable in there. Actually, look at this. I just added 10 instead of that.
It's okay, Puga.
Yeah.
Take over. I have a text message.
Okay. Alrighty, so what I'm going to do is I'm going to put the same variable into my integer, double, and float. So I'm going to put like, I guess like 5. Let's do 5. And I'm going to show you what happens when we divide. So let's go ahead and run it. Compilation. Alright, so we're going to do 5, 5, 5, and then a character. Alright. So for the integer, float, and double, all of them, when you add 10 and the original value is 5, you get 15. So let me go ahead and type E. Alright. So we see here that it's the same thing, except that it's not. What happened here? I guess I added something different in this one. Yeah, I did.
Yeah.
Okay,
You did.
but
Because that's flat 10 and those are your different values.
mm-hmm. Oh, I didn't change the text for this one. Oops. Wow. Actually, that's another good point. The cout statement actually doesn't check for what you're doing. It actually just
prints
says
out stuff.
Yeah. So if you go around copying stuff,
It's going to print exactly what's inside of those quotes.
yeah. And it can be a little bit confusing when you look at the value. And did I even spell that? Yes, I did.
Don't worry, Puga, you're not from this country.
Yeah. Let me just change this real quick just to make it all consistent. Everything has to be consistent. Alright. Now it'll actually say division. 6. Actually.
That's fine. Oh, wow.
I know.
You're a devil,
I barely realized it right now. I was like, oh, not 6. Come on. Whatever. Okay. When we divide 6 by 10, we get 1. Because that is, I guess it didn't completely get rid of it? I've actually never seen that.
Well, it's integer by integer, so it's going to cut off our remainder.
Yeah, but the division of 6 by 10, it's less than 0. So 0 point, no, I mean, it's not less than 0, but it's 0 point something. So you should have chopped it off to 0.
Oh.
Maybe it's weird like that. Let's show it with a bigger number. But the point is, you can actually see, oh, no, it added it to 16. It was actually 16 before that. Okay, so yeah, it just chops the bottom.
16, bro.
Yeah, 16. That's what we had it outputting over here.
Yeah.
Give us a hint over here. Okay, cool. So we actually get the decimal points in here, and in here it chops it off. If you're doing division, rule of thumb, use floats or doubles. If you're going to use integers, probably not going to work unless you're doing something that doesn't require decimal places, I guess. But
which usually is not the case.
Yeah. I've done it only once, one of my programs. Okay, and for multiplication, it is basically the same thing as addition. Let me put something in here so it stops.
Except, okay, so a big common mistake I see, for multiplication, the syntax for multiplication isn't with like an X for times, it's with the star.
Oh yeah.
So just like divide is the slash, it's not the weird regular divide. We're gonna do a multiplication that does I star 10, which means I times 10.
Once again,
you don't have to type out multiplication, just Oh my gosh.
What is your problem, Kevin? I'm trying to learn English. Jerk. What is your problem?
You're never gonna be American, Puga.
What?
Don't hit F3.
No.
Don't hit my number key.
Oh no.
My numpad is.
Actually, I've seen people do this too. You can just quit.
Yeah, Q, enter. Use the num up here.
How come your keyboard doesn't?
I don't
Oh,
know.
actually, my keyboard doesn't do that here. And Slightner,
Yeah.
for some reason, sometimes it doesn't actually listen to the number pad, if that
Yeah,
makes any sense.
your 10 key doesn't like it sometimes.
Yeah.
I think it's because.
There's a lot of little gimmicks that are happening right now. Just weird, right?
Yeah.
This is stuff that actually happened to me when I was coding. From my house, too. Let's see it. Alright, so let's start again. This time I'm going to put 3. 3, 3, 3. And then I'm going to put this character 3. Alright, so we get the addition. So we get 3 plus 10 is 13. 3 plus 10 is 13. 3 plus 10 is 13. All the values are outputting again.
You're really good at math, Puga.
Yeah, I am, sir. This time they actually change. Now they're all 13. And now we're going to start dividing. The division of 13 and 10 is 1. Then the other ones is 1.3. When we multiply 13 by 10, it is 130, 130, 130.
Yep. Looks pretty good, Puga.
Yep. This actually turned out to be a pretty massive program for some reason.
A lot of copy and pasta.
Yeah. I think we are finished with this program right now.
Yep.
I am just going to add this right here.
Good.
Alright. We'll see you guys on the next video. Bye-bye.
Bye.